Okay, so for the second side of the notes, we are going to talk about the mid-segment theorem. Okay, so a mid-segment theorem states that the line segment connecting the midpoints of any two sides of a triangle is parallel to the third and half the length. So let me just highlight all of that. So the line segment connecting midpoints of two sides. So let's go ahead and draw this out. So here is A, B, C. If I take a midpoint and call it X, for the second side, let's go ahead and look at the mid-segment theorem. I'll go ahead and highlight this. The mid-segment theorem states that the line segment connecting the midpoints of any two sides of a triangle is parallel to the third and is half length. So let's go ahead and identify this. So if we try this triangle A, B, C, if I were to find this midpoint between A, B, and call it X, and this midpoint between AC and call it Y, and I connect that line, this line that I just created is parallel. So that's this line right here. That line is parallel to BC, and it is half the length. So I can say XY is equal to half of BC. Another way I could write that is 2 of XY is equal to BC. So that line segment right here, this line segment is connected by two midpoints of this line. They are parallel to that side. Okay, so the little side is half the long side, or the little side is twice, which is equal to the long side. So look at that in practice. So here is my midpoint HG, and that's what we're trying to find, and that is going to be equal to twice or half of that side, or half of SU. Okay, so if I'm trying to find HG, then I'm going to set it equal to half of SU, and I know SU is 14. So half of 14, HG is 7. And that's what I'm trying to find. So half of side is 7. And you should see that if this is my smaller side, I should be smaller than my longest side. All right, let's look at the next one. We have this side. RQ is going to be the little side, RQ. And that is going to be, if I double that, it's going to equal IG, which I'm trying to find. So I'm going to double RQ, and RQ is 6, which is going to equal IG. G, not 6, G, there it is. And so 2 times 6 is 12, which is equal to IG. And again, that should be the bigger side, so make sure that looks the way it is. Okay, so when you get to problems, so those problems above had numbers on them. These two problems are not going to have numbers. We're going to always multiply the short side. So again, here are your two midpoint. So we are going to double short side, which for us is VW, and we're going to set it equal to the long side, which is EC. So 2 times x minus 5 is equal to x, right? And the reason why I had to put these in parentheses because this 2 needs to multiply everything inside. So 2x minus 10 is equal to x. If I don't put that in, then if I don't put that x minus in parentheses, then we won't get this 10 over here and we won't get an answer. Subtract 2x from both sides, I have negative 10 is equal to negative x. And my last thing is to divide by negative 1. So x equals 10. And again, if you were to plug that back in, into your problem, you will see that if I put 10 here, 10 minus 5 is 5, and 10, and that works out. And that would also help you to know if you got it right or wrong. All right, next one, DC are midpoints. So we are going to double DC and set it equal to YW. So 2 times 2x minus 9, and we're going to set that equal to 3x minus 8. Again, I have to put that in parentheses so that it goes to both. That's 4x minus 18, which is equal to 3x minus 8. I'm going to subtract 3x from the 4x. I get x minus 18 is equal to negative 8. Add 18 to both sides, and I get x is equal to 10. Not every time does it equal 10. It just so happens that we set two problems set up to be equal to. All right, getting down to the very last bit, there are some tricks, some quick tricks to help with this. It's going to seem a little complicated at first, but I promise you it will get a little less complicated when we start the problem. So, angles with mid-segments. Since there are parallel lines, chapter 2 is back, mainly corresponding angles. So, we have to kind of remember all of that. Again, here are these midpoints, and we know that they are parallel to the third side of the triangle. So, if we have two parallel lines and we have a transversal, we're going to have corresponding angles. So, this angle right here, ABC, is congruent to AD because they're corresponding. ACB is congruent to AED by corresponding as well. So kind of put those lines. Again, this is a transversal. So those are corresponding. So if we look over at this fun little chart that we have over, or this triangle that we have over here, we have this parallel side. These two sides are parallel. So when you have those two sides parallel, you can see that 60 is congruent there and there because you have parallel lines. Well, let's actually get correct parallel lines. You have these two parallel lines right here. Since two lines are parallel in red, then 60 is congruent because of the corresponding angles. Okay. Then when we look at these lines, we have some more. Whoops. I just want the lines. Okay, there it is. We have this line is parallel to this line. So then we have all of these awesome little angles in here, and let's just highlight all the 60s. As you're going to see, there's a 60 here, like I highlighted 60 there, and then this 60 is congruent to this 60 because they're alternating over the pink line, so they're alternating interior angles. Then if we go through and we see this 30 and this 30, they are alternating interior, and then this 30 and this 30 corresponding. And then if we look at 90, we have 90 and 90, they are alternating over the pink, and this 90 and this 90 are corresponding. Okay. So you'll also notice that we have a ton of little triangles in here. Let's see if I can get some other color. So if we look at that, we have this triangle in here, and if we're looking at this triangle, you'll see that you have a side 7, 6, 3. And then the same triangle with the same angles, you have 7, 6, 3. And then in here, you have the same triangle with 7, 6, 3. And then another triangle with 7, 6, 3. So you would you have so many little of the same triangles. So use what we know with all of that in the mid-segment theorem. Let's go ahead and identify some stuff. How do we apply it? So let's look at this triangle over here. It has nothing labeled other than we have midpoints and we have a little triangle inside. So let's x, y. So x to y is 10, and A is a midpoint. Then this side of A and that side of A are 5 and 5, which means B and C are midpoints. Then that side is also a 5. If we know x to z is 12, then x to b is 6, and b to z is 6. And then the side that you see are midpoints that is parallel to that is also 6. If we know y to z is 14, then we know y to c is 7, and c to z is 7, which means that from A to B is also 7. And that's what we have. AB is 7. Then the perimeter of this little triangle here that we have will be 7 plus 6 plus 5, and 7 plus 6 plus 5 is 18. So that perimeter for that triangle is 18. Then we get into the angles. And this kind of gets a little messy in here, but we'll try to clean it up. So y is 63 degrees. And if y is 63 degrees, and as you can see, it's 5 and 7. So 5 and 7, that's also 63 degrees. And then if we go 7 to 5, this is also 63 degrees. And then 5 to 7 is all 63 degrees. Okay. And if we are looking Z, C, B, Z to C, B, that is 60 degrees. And then X to A to B, so X to A to B is also 63 degrees. Now we're coming back to information. Angle X is 75 degrees, so that is 5 and 6. So 5 and 6, 75 degrees. This is 5 and 6, 75 degrees. Ooh. 5 and 6, 75 degrees. So alternating, corresponding, and corresponding. Finding. Oh, they're all done there. Okay, so Z, B, C, Z up to B to C is 75 degrees. And then the last one we want to find is angle Z. So this angle right here. And if we know that the big whole triangle, we know 75 and 63, so we're going to go 180 minus 75 minus 63. So 180 minus 75 minus 63 is 42 degrees. And there you go.